Okay, so we're going to start talking about the material in Chapter 5, which covers Bootstrap distributions. So these slides are going to more or less follow along the worksheet, the first part on Bootstrap distribution, so it might be helpful to have that worksheet handy and follow along. So what we're going to do in this chapter is think about situations where we don't have all of the information about the population, but we still want to use sampling distributions to come up with some estimates about the population. So for example, we've been working with sampling distributions already, and in these cases, they pretty much fall into a couple of different types. And so on the one hand, we've been dealing with situations where we know exactly what the population looks like. So for example, last notes, we had a gamma distribution where we were thinking about how long is it going to take someone to catch 5 fish, and in that case, we knew exactly what the population looked like, and then we were able to come up with some estimate about what some reasonable sample statistics might be. In the case of doing hypothesis tests in Chapter 3, in those cases, we make an assumption about the population. So, for example, when we were dealing with the flight data from airlines, although we didn't have all of the data from those airlines, we would make a claim like there's no difference between United and American airline flight delays. And then we set up a simulation using a permutation test to look at what are reasonable sample statistics. So in that case, we use some simulations to construct a sampling distribution based on some claim about a population. So the question might be, well, what happens if I don't have any claim in mind about a population, but I want to come up with an estimate, like what is the mean delay time for United flights? So there's no claim about that value. I don't have access, so I don't know what the population mean and standard deviation are. So how can I create a sampling distribution and then answer some questions based on that sampling distribution? So that's going to be the goal of Chapter 5, is to think about how from one sample we can generate an estimate for a sampling distribution. Okay, so here's the first example that we'll think about to get the ball rolling on this. So we're going to use a data set called NC Births 2004. So this is from our textbook. So if you load the library resample data, that data set will be in there. And so that data set contains a random sample of 1,009 newborn babies in North Carolina in 2004. And if you look at the data set, you'll see there's a number of variables in there, such as the mother's age, whether the mother used tobacco or not, what gender was assigned to the baby at birth, weight, and the gestation period, how long was the mother pregnant when the baby was born. So we'll take a look at this data set in some other cases moving forward. And if we say wanted to come up with an estimate, which is what this question is saying, what is a good estimate for the mean weight of all babies born in North Carolina in 2004? Well, being that we have this data set of 1,009 babies, this is not all of the births, so this is a random sample of births, then we could use our, for example, we can load up the library resample data and then calculate the mean of the variable weight inside of this data set. And what we see here is that the mean weight of newborns was 3,448.26. And here what we should note is that we're measuring this in grams. So this would be a good starting point for our guess, right? If someone asked you, here's a data set of 1,009 babies, we want to come up with an estimate for what the mean weight of all babies would be, this would be probably your first starting point was, let me calculate the mean of my sample. And a couple of points here, and that is, first of all, this sample was random. and it's pretty large. There's over 1,000 values in here. So it should be a really good representation of the population. It is not going to be perfect because it doesn't contain everybody from the population, but this should be a reasonably good estimate. The question is, how reasonable, how much error should we build into that estimate? So it's not going to be exactly 3,448. What would be a reasonable amount of error that we can attach to that estimate?